So the next couple of lectures I'm going to talk about is about heat, the transfer of energy, thermal energy to an object and how it interacts with matter. The first one I'm going to talk about is a real simple relationship, and that's heat and thermal expansion. So if we were looking at what was going on when we were talking about properties of matter and how it's interacting, is that when you start applying heat to an object, it starts gaining kinetic energy. If it starts gaining kinetic energy, it's starting to move a lot more. So when we talk about, sorry, just making sure I wasn't crushing my cord. So when we talk about introducing a heat, we're giving it kinetic energy, meaning that the particle is taking up more space. So the first property is what's called thermal expansion. And the relationship in thermal expansion is the change in the length of an object is dependent on several things. The first being the original length of the object. So a longer object, if you heat it up evenly, that means it has more particles. More particles are wanting to expand. Therefore, the change in its length is dependent on the length of the object, the original length of the object. Then multiplied by a linear thermal expansion coefficient. Now that's something that's intrinsic to the material. Certain objects will have higher linear expansion, thermal expansion. Some objects will have lower. As a matter of fact, our heavy-duty fuses that are in our house rely on this principle. If you run a bimetal through there, copper on one side, aluminum on the other, the objects will be heated up evenly. They should experience the same temperature. But because of the property of this linear thermal expansion, one object will, or one metal will gain more length than the other. And if they're basically welded together, let's say, imagine that the bottom one has more thermal expansion, it'll actually force the object to bend. Okay? So therefore it'll break the switch. So if it gets too hot, it'll break the switch, which is a great thing because it means that there's too much current traveling through it, which is something that you want to avoid. The other component of it is the amount of temperature that's being introduced. Now, important thing is the change in temperature. It's not referring to the temperature, but the change in its temperature. So if it's a drastic change in temperature, then you expect a drastic change in its length. Okay, so that's the first property of matter when talking about heat. I've got two more to talk about, but that's what we're going to start with.